Welcome to our discussion on incidence and prevalence. This is the first of 3 topics that we will be covering in the general area of measures of frequency. And so we'll be also looking at some common measures of morbidity and mortality, as well as the whole concept of standardizing these rates. So first of all, we need to lay the groundwork of what exactly we are looking at with incidence and prevalence. And so to start off that conversation, there are 4 different ways that we could measure these kinds of things. So let's define those right off the bat. First of all, the count is just literally a number. I'm going to put n here. N is just, let's say we're looking at a particular group somewhere and we notice that there are 10 cases of some disease. That we're just counting them. We're not making it relative to anything else. And so we just notice the number of cases. With a ratio, on the other hand, that's when we start incorporating denominator data. And so I'm going to put here that a ratio is a numerator compared to a denominator. And really, this is relating one quantity to another. And so we have the numerator is divided by the denominator, and so then we get this comparison between those two groups. And so a ratio is just a general term. Both proportion and rate then are special cases of ratios that have a specific definition. A proportion means that the people who are in the numerator are also included in the denominator. And so I'm going to denote that by saying the proportion is A over A plus B. In other words, everybody who's here in the numerator is also included in the denominator data, which is not true of a general ratio variable. The denominator may or may not include the numerator, the people who are in the numerator. A rate takes that even farther, and not only does the denominator, A plus B, include all the people in the numerator, but also it is expressed as a time variable, as a per time. Now, the most common way of thinking about a rate, an easy way of thinking about a rate, is miles. I have to be careful where I put my hand. Miles per hour. Let me try to erase some of that. We don't need to have all this over here. So if we think about miles per hour, that tells us how fast something is happening. And so a proportion may just be like how many miles does your car have, whereas a rate would be how fast those miles are happening in a specific unit of time. And so there's a little bit of a distinction there. And I have to just say that in epidemiology, the problem with really focusing in on that is that there are a lot of things that are in the gray areas in between. And so that distinction is important to people who are very specific with the way they define things. And as long as you understand how a particular study is put together, then you will understand whether it's a proportion or a rate, but that distinction is often not clear. People use the term rate for things that are not rates, and people may talk about proportions or percentages for things that are actually ratios. And so it becomes very gray, even in the way that trained public health professionals use these terms, but understand that there are a variety of different ways that we can measure things, and to some people it's very important that we use the terms rate and proportion and ratio properly. All 3 of them have denominator data, and it's just what is included in the denominator makes those 3 different. Okay, so now that we've defined counts, ratios, proportions, and rates, one of the things that I like to look at early on is the whole thing about why. Why would we even want to calculate these counts, ratios, proportions, and rates? And the reason that we would do things, instead of just using counts all the time, the reason that we would try to be over here in the proportion and rate area is that we want to compare. We want to compare one population to a different population. We want to compare what it was like 10 years ago to right now. And so if we're going to be making those comparisons, then we need to have a pretty standard way of defining who that denominator is. If we just say that the count, the overall count over here, kind of like in this column, was a certain number, but now it's gone up, we don't know if that's because the whole population has gotten bigger, or we're looking at a larger group or a smaller group than we were at a certain time longer ago, or if we're comparing two groups that aren't the equal size. So the main reason that we like to be over here on the right-hand side with proportions and rates is that we want to be able to compare between two time periods or two different populations. And just as a kind of a quick, I have percentage here. A proportion, all of these things are often displayed per a certain number, so per 1,000, per 100,000. Percent is literally per 100. Cent is 100. So a percentage is per 100 people. So we often will report these kinds of things in a standard number so that we can do this comparison across different populations or time periods. So let's take a look, and I'll draw the rest of these columns here. Let's take a look at what we would like to do with a couple of things. There are two primary things that we like to count. And those two things are, we like to count the number of existing cases, and we like to count the number of new cases. Now, why would we want to count the number of existing cases? The answer to that is, and I'll just put Y over here, we might want to know how many health services we need. So we need to know how many hospital beds, or we need to know how many clinics, or how many nurses, or all that kind of thing. If we have this existing pool of people, you know, here we have our people that need this particular thing because they have this disease or they have this whatever. We need to know in terms of health services, we may be trying to sort of define what is the health burden. And so these are both related to the disease or the outcome. We may also want to know something about the frequency of exposure, or we may want to know the frequency of a particular risk factor. These can all be measured in terms of the number of existing people who have this particular exposure or this risk factor. And so these are predictors of disease. So we can use these things in terms of the number existing to measure all kinds of things. It's not just a particular outcome. In terms of the number of new, a lot of times we want to know about disease etiology, kind of the causality piece, and we also want to know here about primary prevention. And if you remember, primary prevention is among people who do not have the disease, and I like to draw this as a kind of a picture. Let me give myself a little bit more space down here. Let's say we have, whoops, I guess I have to have that. No disease. And once we cross this line right here, then we have disease. And here's our discussion about existing cases. We are trying to move them over here into the no disease. But if somebody has disease already, then we're talking about secondary and tertiary prevention. We want to move those people out of the pool of people who have existing disease, or at least we need to be thinking about treating them. And so that's one of the questions we can have. If we have people with new disease, they started out with not having disease, and they had to have moved in that direction in order to get the disease. So we're thinking here in terms of etiology, how did they get there, right? Or in terms of primary prevention, how can we block that so that we either are doing primary prevention as health promotion type activities, kind of moving them in the direction of more health, or we're blocking them with things like immunizations that prevent them from becoming a new case. And so if we think about this in terms of here we have no disease and here we have disease, the existing and the new disease are really operating in opposite directions. Existing disease, the reason that we want to look at those particular people is so that we know how to serve them. For in terms of new diseases, we want to know how did they get there and what can we do to prevent that in the first place, that primary prevention. Okay, so that was kind of a little bit of an aside. And so I'm going to create here sort of a top row for us to talk about the existing cases, and then a bottom row for us to talking about the new cases. I'm also going to I'm going to erase this piece down here because I'm going to need some space down here. So that was just kind of my little aside. All right. Okay. So let's give these two things a name now. If we are thinking about the number of existing cases, this is known as prevalence. And this is really a heading for the entire, all the way across, all of these different categories. This bottom row, the number of new cases, is known as incidence. Again, this is kind of for all of the categories, all the way across: count, ratio, proportion, and rate. And so if we're thinking about prevalence, we really want to know how many are there. And so a good example of that in terms of the count here would be sometimes these are uncommon diseases like smallpox, other infectious diseases. In terms of prevalence, that could be, you know, the number of people at a particular school that have the common cold. How many nurses will it take to take care of those people? A ratio, a good example of a ratio that we do use in public health is something called the sex ratio. And a lot of times we're thinking about the sex ratio at birth. Like we want to know how many male babies are born compared to female. And the number of male babies born is actually typically a little bit higher than the female babies. And so we'll say male to female babies. And if you are looking in a textbook, you'll often see that this is like for every 1,000 female babies, we have maybe 1,042 or 56 or whatever male babies. So you can see that ratio, and then you can see if that's changing over time for a particular area, or if it's remaining fairly constant. If it's if there are a lot more male babies in a particular area, that may indicate gender preference. So those are the kinds of things that you could look at with a ratio. And notice we have a numerator and we have a denominator, but it's not a proportion because the male babies are not in the denominator. They are only in the numerator. As soon as we have the numerator within the denominator, then we call that ratio something specific. We call it either a proportion or a rate, and so we'll get to that. An example of a ratio would be, and I'm going to put here fetal death ratio. And again, There's an example in probably most textbooks where you have the number of fetal deaths, which is defined as the number of intrauterine fetal, sometimes they're called miscarriages or stillbirths, that kind of thing, over the number of live births. And so you'll notice that the fetal deaths is not included in the denominator here. So this is called the fetal death ratio. And notice here we even have correctly identified it as a ratio and not a rate. So, and here we also have a sex ratio. So anytime we call something a ratio, specifically we are acknowledging that that numerator is not in the denominator. So those are some good examples of ratios. Now, a ratio can be specifically a proportion as well. And if we're thinking about the number of existing cases, then we start calling these some specific things. And so let me draw the equation for a proportion. We would have, in terms of existing cases, we would have the number of existing cases divided by the total population. And this is cases plus non-cases. So you'll see now that the numerator is included as part of the denominator. And this specific definition is also known as the point prevalence, is equal to this existing cases over the total population. We'll come back and we'll talk about one other kind. Before I continue on, I do want to add one more thing, that whenever we are thinking about these kinds of counts and ratios and proportions and rates, a lot of times we're thinking about the who, the where, and the when. Specifically, who is our population, where in terms of a location, and when is the time or period of observation. Now, a lot of times when you see an actual proportion or rate or count or ratio expressed, they may not specify the location or the time period, but it's implied. And so it may say currently, blah, blah, blah. And what that does is it implies that the current time or period is this year. So even though it's not necessarily specified, a lot of times it is still implied to be a particular place. And again, here we have our per 1,000 or per 100 or per 100,000. A lot of times we try to create a number where our numerator, or the reported number, ends up being a full integer. So instead of reporting things as 0.005, we would want to adjust that so that it's a per 1,000 or per 100,000, so that we get full integers, because it's much easier to look at those. It's not that they're wrong if it's a decimal point. It's just that it's harder for the average person to comprehend or interpret it. Okay, so in terms of incidence, if we're going back to our table that we're filling in here, in terms of incidence, we're a lot of times looking at if it's a proportion, we want again to know the number of new cases. Remember, incidence is the number of new cases, divided by the population at risk. And so hopefully you're seeing a difference between here with prevalence and incidence. Both the numerator and the denominator are different. Existing cases could have happened at any point in history, all the way up until this point where we took the point prevalence. Whereas the incidence, we start at whatever, time 0, and follow them forward for a specific time period, and we want to know how many new cases there are. And so at the beginning of that time period, we really only want to include the population that is at risk for becoming a new case. If we include people that can't become cases, then we have this proportion that doesn't reflect the true incidence of disease. And this is the population at risk at the beginning of whatever that time period. Now you may hear this called all kinds of different things. So in terms of this incidence here, you may hear it called just plain old incidence. Another term is incidence proportion. So you'll see here's incidence, here's proportion. So you might hear people call this incidence proportion. You might hear people call this the probability of getting a disease. You might hear people call this the risk. And I'm going to put a square around that because risk is a very important concept here. The risk of getting a disease. So the risk of diabetes, the risk of whatever. So very often you'll hear those kinds of terms for that. Other words are some of the specific things, and we'll get into that when we have our next video in terms of the common measures of morbidity and mortality. Now, I'd also like to talk about this whole concept of rate. And one of the important things to remember is that prevalence is not a rate. Remember how we talked about miles per hour? If you start out with all the existing cases, all the miles that you already have on your car, and then you try to use that number to calculate miles per hour that's happening in a designated time period, it's not possible to do that. So that analogy isn't perfect, but hopefully it'll help you see that prevalence is not a rate. So the kinds of things that we do with prevalence end up being proportions rather than rates. And it's because we include all of the existing cases. So the main thing that we're going to do with rate is going to be an incidence rate. And so I'll put the definition here is the number of new cases divided by what we call person time. And so it would be, let's say we have a certain number of new cases per year, a certain number of deaths per year, a certain number of births per year. And so this per time is going to be the key piece of defining this as a rate. Remember, this is miles per hour. And so this is cases per year. And again, we may have this per 100,000, per 1,000, kind of in order so that we can have a standard comparison across different times or different populations. But so, and that's your persons, but it's cases per time. And so that's where this gets to be a little bit more specific in terms of etiology. And you may hear this called, I'll put some words down here, incidence. So here we go, there's this confusion. You may hear this called incidence density. You may hear it called a rate of disease. And here I'm going to put a box around this again, because here we have risk and here we have rate. And those are two kind of different things that we're doing. You may hear this called an incidence rate. And so these are all very confusing terms that are not used properly by a lot of different people, including people who are researchers and scientists. So you can see why there's this confusion between proportion and rate. And in reality, as long as you are using things like probability of disease or incidence rate or incidence density, as long as you're using those kind of terms, people understand what you're talking about, and it's not as important to really be clear about what things fall into rates and what things fall into proportions, because it's how we use them in epidemiology that's much more important. this whole person time concept deserves a little bit more attention. Ideally, person time would be calculated for each person in your data set. In other words, you would start at the beginning of when you observed them. You would follow them forward in time until they either became a new case, they maybe die of something else, so they leave the study. They may move away, so we can't keep following them, or the study may end, and we don't keep following them forward anymore in time. And so that amount of time that we followed them becomes a certain amount of time, and each person in the study would have a different amount of time that we follow them, depending on when we start and when those particular events happen that could take them out of the person time pool. So each person that would then be multiplied by 1 month or 8 months or 12 months or 2 years or however long they're followed forward in time, that is the strictest definition of this person time denominator. Now, denominators are actually trickier than that. One of the big challenges in epidemiology is finding and enumerating the denominator. And so we think, oh, well, we'll just find out what the total population was, or we'll just find out what the population at risk was, or we'll find out what this person time was. And it's almost never that simple. You think you have a good population, that is your cases plus non-cases for prevalence, and as it turns out, somehow it includes other people, or it doesn't include some of the people that you want it to include. So finding that denominator data can be somewhat problematic. So a lot of times we'll use something that's a good estimate. And sometimes for this person time data, we may just take the year, like let's say it's for 2014, given a specific year, we may estimate that person time by just saying, well, how many people were in that population at mid-year, say July 1. And so we're trying to do our best to find this person time denominator, but we can't always get it to be perfectly accurate. The ideal person time would look more like this. Every single person would be followed for a specific amount of time, and you would know when one of those outcomes happened. Either the study ended, they left the study for some reason, they died from some other cause, or they moved away, or they became one of the cases that becomes the numerator. So there are a lot of reasons why we can't always get really accurate proportions and rates. And so comparing across populations sometimes is a little bit trickier and not as exact of a science as we would like it to be. So that concludes my overall picture. Oh, actually, there's one other thing that I want to show you in terms of prevalence and incidence. There is a picture, and it's kind of like a little bathtub thing. I'll put some little feet on it, make it a Victorian one. And then if here's the wall, and we have the water faucet. And here's a good amount of water that's in that tub. The water that's in the tub really represents the prevalence. And so this is the number of people who have that existing condition, and we are trying to find health services or the health burden or to cure them or to determine the exposure or the risk factors. So this is kind of like the secondary and the tertiary prevention. So this prevalence level really tells us how big that group is, how many people are there. The incidence is the water dripping out of the faucet. That's the new cases that are being added to this tub. And so if we think about the etiology, and here's our primary prevention, if we were to cut off and totally block this so that there are no more drops going in by either some great health promotion or immunizations or some kind of primary prevention, then we have primarily affected the incidence. If you want to see a mathematical relationship between prevalence and incidence, what we have is prevalence is equal to incidence times duration. So if incidence goes up, it indirectly makes prevalence go up. So if we are cutting off this flow of water into the bathtub, it definitely, absolutely affects incidence. And depending on what happens then with duration, it might also affect prevalence. So if duration goes up, if people start living longer with the disease, then that can also increase the prevalence. So both of those things can happen. Now, the problem with identifying that these kind of primary prevention methods will impact prevalence, they may or they may not, because if the incidence goes down, because here we are giving immunizations, or we're giving these great health promotion activities that are being effective, that increasing incidence sometimes affects the duration in the opposite direction, and so prevalence may end up actually staying the same. It's probably not very common for that to happen, but the point of this is that if we do these primary prevention methods, we directly impact incidence. So we know absolutely for sure we're going to be impacting the number of new cases. That may also impact prevalence, but sometimes it doesn't. We think it's going to, but depending on what happens here with duration, it may not impact the prevalence of the disease very much, especially if incidence is fairly small compared to the prevalence of that disease, such like as in terms of HIV. Now, if we are doing these kinds of things that are secondary and tertiary prevention, you could imagine that as sort of the water evaporating. We cure the disease. And so that primarily impacts the prevalence of the disease. You can do all you want to cure people, and it may indirectly impact the incidence because maybe there are fewer people out there that are infectious. But we know for sure that secondary and tertiary, if they're effective, will impact prevalence. They may or may not impact incidence. So just kind of keep those two things in mind. And it has to do with a lot of other factors that are external to those kinds of activities, the secondary, tertiary prevention and the primary prevention. So this relationship between prevalence, incidence, and duration is another really helpful way of thinking about it. The only other thing that decreases prevalence is for somebody to move away or die. So if we somehow find a way of keeping people from dying, that actually increases the prevalence because it increases the duration. And so monitoring prevalence may not be the best way to monitor our effectiveness of treating the disease, especially if we're preventing people from dying and causing them to be a prevalent case. So there are limitations to all of these different kinds of things that we do in epidemiology, the ways that we study things. So just keep that in mind as you are going out into the world and being a public health professional. That concludes our video for this particular topic, and then next we'll move on to looking at some common measures of morbidity and mortality.